Hello friends, welcome back to i-TUTOR NCERT series. Today we will be discussing Class 11 Geography NCERT, India Physical Environment, Chapter 4 Climate. In southern India, woolen clothes are not required, and in northeastern states, winters are mildly expected in the hills. Okay, so this is some introduction about the Indian climate. There are variations in weather conditions during different seasons. These changes occur due to the changes in the element of weather. That is, the elements are temperature, pressure, wind direction, and velocity. Then humidity and precipitation. So these are some of the elements which can make changes in the weather condition. So what are they? The first one, temperature, pressure, wind direction, velocity, humidity, and precipitation. Now, we know what is the difference between weather and climate. Weather is the momentary state of atmosphere, while climate refers to the average of the weather condition. Okay, so weather is the momentary state or the day-to-day condition of the atmosphere. But at the same time, what is climate? Climate refers to the average of the weather. Okay, so climate is the average of the weather condition over a longer period. Weather changes quickly, maybe within a day or week, but climate changes imperceptibly and may be noted after 50 years or even more. Okay, so the weather can be changed today or tomorrow, but the climate is not like that. It can be noted after 50 years or even more. Okay, so that is the difference between weather and climate. Now, monsoon connotes the climate associated with seasonal reversal in the direction of winds. India has hot monsoonal climate, which is the prevalent climate in South and Southeast Asia. Okay, so India has the hot monsoonal climate and which is prevalent climate in the South and Southeast Asia. Now moving forward, unity and diversity in the monsoon climate. The monsoon regime emphasizes the unity of India with the rest of Southeast Asian region. This view of broad unity of monsoon type of climate should not, however, lead one to ignore its regional variation with differentiate the weather and climate of different regions of India. For example, the climate of Kerala and Tamil Nadu in the south are so different from that of Uttar Pradesh and Bihar in the north. And yet all of these have a monsoon type of climate. Okay, so we know the climate of Kerala and Tamil Nadu is entirely different from the climate of Uttar Pradesh and Bihar. Okay, sorry, give me a minute. And now, the climate of India has many regional variations expressed in the patterns of winds, temperature and rainfall, rhythms of season and the degree of wetness or dryness. These regional diversities may be described as subtype of monsoon climate. Okay, so in every place or in any region, there is a regional variations expressed in the patterns of winds, temperature and rainfall, rhythm of season and the degree of wetness and dryness. So these diversities or these regional diversities may be described as a subtype of monsoon climate. Now, while in the summer of the mercury occasionally touches 55 degrees Celsius in the western Rajasthan, it drops down to as low as minus 45 degree in winter around Leh. Okay, so the summer temperature in western Rajasthan may be 55 degrees Celsius, but at the same time it drops down as to low as minus 45 degrees Celsius in winter around Leh. Now, Churu in Rajasthan may record a temperature of 50 degrees Celsius or more on June day, while the mercury hardly touches 90 degrees Celsius in Tawang, that is in Arunachal Pradesh, on the same day. Okay, so in the June month, Churu in Rajasthan may record a temperature of 50 degrees Celsius or more, but at the same time, the Tawang in Arunachal Pradesh, it hardly touches or it only record 90 degrees Celsius. Okay, so that's very low temperature. On a December night, temperature in Dras, that's in Jammu and Kashmir, may drop down to minus 45 degrees Celsius. Okay, so in December, that is in the winter season, the temperature in Dras in Jammu and Kashmir, it may drop down to minus 45 degrees Celsius. While Trivandrum or Chennai on the same night record 20 degrees Celsius or 22 degrees Celsius. Okay, so at the same time, the southern states, they record, or southern districts or southern places, southern regions, they have only 20 degrees Celsius or 22 degrees Celsius. These examples confirm that there are seasonal variations in temperature from place to place and from region to region in India. Okay, so there is a seasonal variation in temperature from place to place or region to region. Not only this, if we take only a single place and record the temperature for just one day, variations are no less striking. In Kerala and in the Andaman Islands, the difference between day and night temperature may be hardly 7 or 8 degrees Celsius. But in the Thar Desert, if the day temperature is around 50 degrees Celsius, at the night it may drop down considerably up to 50 degrees Celsius to 20 degrees Celsius. Okay, so if we take Kerala or Andaman, then the difference between day and night temperature may be hardly 7 or 8 degrees Celsius. Okay, there is only a difference between 7 or 8 degrees Celsius. That is difference between the day temperature and the night temperature. But in the Thar Desert, okay, Thar Desert in Rajasthan, it have day temperature is around 50 degrees Celsius, but at the night temperature may as low as 15 degrees Celsius or 20 degrees Celsius. Okay, so there is a big difference between the day temperature and the night temperature. While snowfall occurs in the Himalayas, it only rains over the rest of the country. Similarly, variations are noticeable not only in the type of precipitation, but also in its amount. While Cherrapunji and Mozoram in the Khasi hills of Meghalaya receive rainfall over 1080 cm in a year. Okay, so the Cherrapunji and Mozoram, that's in the Khasi hills of Himalaya, it receives a rainfall over 1080 cm in a year. But at the same time, Jaisalmer in Rajasthan, it rarely gets more than 9 cm of rainfall during the same period. Okay, so in the east side, that is in Cherrapunji and Mozoram, that's in Meghalaya, it receives rainfall over 1080 cm. But at the same time, the Jaisalmer and Rajasthan get only 9 cm. Okay. Tura situation in the Garo hills of Meghalaya may receive an amount of rainfall in a single day, which is equal to 10 years of rainfall at Jaisalmer. Okay, so Tura situated in the Garo hills of Meghalaya, it receives an amount of rainfall in a single day. The single day amount of rainfall is equal to the 10 years rainfall at Jaisalmer. Okay, so the Tura's one day rainfall is equal to the 10 years rainfall at Jaisalmer. So that is the difference. While the annual precipitation is less than 10 cm in the northwest Himalayas and the western district. Okay, the northwest Himalayas and the western deserts, the annual precipitation is less than 10 cm and it exceeds 400 cm in Meghalaya, but at the same time it is above 400 cm in Meghalaya. Okay. Now, the Ganga Delta and the coastal plains of Orissa are hit by strong rain-based storms almost every third or fifth day in July and August, while the Coromandel coast, 1,000 km to the south, goes generally dry during these months. Most part of the country get rainfall during June to September, but on the coastal areas of Tamil Nadu, it rains in beginning of the winter season. Okay, so that is because of the retreating monsoon. We already discussed about that. In spite of these differences and variations, the climate of India is monsoonal in rhythm and character. Okay, so that's about the introduction part of our Indian monsoon or Indian climate region. Okay, and the variations of climate in India. Now, factors determining the climate of India. India's climate is controlled by a number of factors which can be broadly divided into two groups. That is, the factors related to location and relief and the factors related to air pressure and winds. Okay, so these are the two groups. Okay, the factors which affected the Indian climate. First one, the location and relief. Then next one, the factors related to air pressure and winds. So first, factors related to location and relief. The first one is latitude. You already know that latitudinal and longitudinal extent of India. Okay, so we know what is the latitudinal and longitudinal extent of India. You also know that Tropic of Cancer, okay, that is 23.5 degree north. Tropic of Cancer that passes through the central part of India in east-west direction. Thus, northern part of the India lies in the subtropical and temperate zone. Okay, so the northern part of India lies in the subtropical and the temperate zone, and the part lying south of Tropic of Cancer for the tropical zone. Okay, so we know if this is India, this is Tropic of Cancer. Okay, so the Tropic of Cancer passes through India. At the same time, here this is equator. So above the Tropic of Cancer, at the places, okay, the northern states, they experience subtropical as well as temperate zone. Okay, so the climate of this area is subtropical or temperate zone, but below the Tropic of Cancer. Okay, then because it is near to the equator, okay, these areas are near to the equator, so these places or this area experience tropical zone. Okay, these areas are tropical zone. Now, the tropical zone being nearer to the equator experiences high temperatures throughout the year with small daily and annual range. Okay, so this area, the tropical range or tropical zone, experiences equatorial climate. Okay, largely equatorial climate, and they experiences high temperature. Area north of Tropic of Cancer being away from the equator experiencing extreme climate with high daily and annual range of temperature. Okay, so the area north of equator, these areas, okay, above the Tropic of Cancer, these areas experiences very extreme climate. Okay, extreme climate. So that is the latitudinal difference. Next one is the impact of Himalayan mountains. Okay, the lofty Himalayas in the north along with its extensions act as a effective climate divide. Okay, so the Himalayas act as an effective climatic divide. The towering mountain chain provides an invisible shield to protect the subcontinent from the cold northern winds. Okay, so the towering mountain chains provide an invisible shield to protect the subcontinent from the cold northern wind. These cold and chilly winds originate near the Arctic Circle and blow across Central and Eastern Asia. Okay, so this cold and chilly wind, this originate near the Arctic Circle. Okay, so it originate near the Arctic Circle and blow across Central and Eastern Asia. The Himalayas also trap the monsoon winds, forcing them to shed their moisture within the subcontinent. Okay, so the Himalayas stop the monsoon winds and it forces them to shed their moisture in the subcontinent. Okay, it helps for the rain in India. Now third one is distribution of land and water. India is flanked by Indian Ocean on three sides in the south and girded by a high and continuous mountain wall in the north. As compared to landmass, water heats up or cools down slowly. Okay, we know compared to land, water heats up and cools down slowly. This differential heating of land and sea creates different air pressure zones, different seasons in and around the Indian subcontinent. Okay, so the differential in heating of land and sea, this creates difference in the air pressure zones. Difference in the air pressure zones in different seasons in and around the Indian subcontinent. Difference in air pressure causes reversal in the direction of monsoon wind. Okay, so the difference in air pressure, this creates the reversal in the direction of monsoon wind. Next, distance from the sea. Okay, so we already discussed about the factors related to location and relief, that is latitude, the Himalayan mountains, distribution of land and water. Next, the distance from the sea. With a long coastline, large coastal areas have an equable climate. areas in the interior of India are far away from the moderating influence of sea. Okay, so the interior places of India are far away from the moderating climate because of the moderating influence of sea. Such areas have extremes of climate. That is why people of Mumbai and Konkan coast have hardly any idea of extremes of temperature and seasonal rhythms of weather. On the other hand, the seasonal contrast in weather at places in the interior of the country such as Delhi, Kanpur and Amritsar affect the entire sphere of life. Now, next one is the altitude. Temperature decreases with height. Okay, we know the temperature decreases with height. Due to thin air, places in the mountains are cooler than places on the plains. For example, Agra and Darjeeling are located on the same latitudes, but temperature of January in Agra is 16 degrees Celsius, where it is only 4 degrees Celsius in Darjeeling. Okay, so if the height increases, temperature decreases. Okay. Now, next one is a relief. The physiography or relief of India also affect the temperature, air pressure, direction and speed of wind and the amount and distribution of rainfall. Okay, so the physiography or the relief, it affects the temperature, air pressure, direction and speed of wind and the amount and distribution of rainfall. The windward side of Western Ghats and Assam receives high rainfall during June-September, whereas the southern plateau remains dry due to its leeward situation due to the Western Ghats. Okay, so at the time of monsoon time or at the time of June to September, the windward side of Western Ghats and the Assam, they receive high rainfall during the June-September months. But at the same time, the southern plateau remains dry due to its leeward situation along the Western Ghats. Okay. Now, next one is factors related to air pressure and wind. Okay, so here we discussed about the factors related to location and relief. Now, the factors related to air pressure and wind. To understand the differences in local climate of India, we need to understand the mechanism of the following three factors. First one, distribution of air pressure and winds on the surface of Earth. Next, upper air circulation caused by factors controlling global weather and the inflow of different air masses and jet streams. Third one, inflow of western cyclones, generally known as disturbances during the winter season and the tropical depression during the southwest monsoon period into India, and which create weather conditions favorable to rainfall. The mechanism of these three factors can be understood with reference to winter and the summer seasons of the year separately. Okay, so these mechanisms can be understood with the reference to winter and summer seasons. So let's discuss the mechanism of weather in the winter season. Okay, so first the mechanism of weather in winter season. First one is surface pressure and winds. In winter months, the weather conditions over India are generally influenced by the distribution of pressure in the Central and Western Asia. Okay, so the winter condition in India is generally influenced by the weather conditions are generally influenced by the distribution of pressure in the Central and Western Asia. A high pressure center in the region lying to the north of Himalayas develops during winter. Okay, so at the time the north of Himalaya have a high pressure center. This center of high pressure gives rise to the flow of air at a low level from the north towards the Indian subcontinent and south of mountain range. The surface winds blowing out of the high pressure center over Central Asia reach India in the form of a dry continental air mass. Okay, so the surface wind that blowing out of the high pressure center over Central Asia that reaches India in the form of a dry continental air mass. These continental winds come in contact with the trade winds over northwestern India. Okay, so these continental winds, they contact with the trade winds in the northwestern India. The position of the contact zone is not, however, stable. Okay, so the position of this contact zone, they are not, however, stable. Occasionally, it may shift its position as far east as the middle Ganga Valley, with the result that the whole of the northwestern and northern India up to the middle Ganga Valley comes under the influence of dry northwestern wind. Okay, so because of this, what happened? The east as position as far east as the middle Ganga Valley, with the result of the whole of the northwestern and northern India up to the middle Ganga Valley comes under the influence of dry northwestern wind. Okay, so this caused the dry northwestern winds. That is the mechanism of surface pressure and the winds. Next one is jet streams and upper air circulation. The pattern of air circulation discussed above is witnessed only at the lower level. Okay, so the above one is only located on the lower level. Now, lower level of the atmosphere near the surface of the earth. Higher up in the lower troposphere, above 3 km above the surface of the earth, a different patterns of air circulation is observed. So, at the troposphere, lower troposphere, okay, higher up in the lower troposphere, about 3 km above the surface of earth, we have a different patterns of air circulation. The variation in the atmospheric pressure closer to the surface of the earth have no role to play in the making of upper air circulation. All of Western and Central Asia remains under the influence of westerly winds along the altitude of 9 to 13 km from west to east. These winds blow across the Asian continent at latitudes north of Himalayas, roughly parallel to the Tibetan highlands. These are known as jet streams. Okay, so these winds, they blow across the Asian continent at latitudes north of the Himalayas, roughly parallel to the Tibetan highlands, and these are known as jet stream. Tibetan highlands act as a barrier in the path of these jet streams. As a result, the jet streams get bifurcated and one of its branches blow to the north of the Tibetan highlands, while the southern branch blows in the eastward direction south of Himalayas. It has its mean position at 25 degree north in February at 200 to 300 MB level. Okay, it is believed that this southern branch of the jet streams exercise an important influence on the winter weather in India. Now, next one is western cyclonic disturbances and tropical cyclones. The western cyclonic disturbances which enter the Indian subcontinent from the west and the northwest during the winter months. Okay, so what is the time period of, or what is the time of western cyclonic disturbance erased India? It distributed which enter Indian subcontinent from the west and the northwest during the winter months, and it originates over the Mediterranean Sea and are brought into India by the westerly jet streams. Okay, so this blow or this originate over the Mediterranean Sea and they are brought into India by the westerly jet streams. An increase in the prevailing night temperature generally indicates an advance in the arrival of these cyclone disturbances. Okay, so an increase in the prevailing night temperature, this generally shows an advance in the arrival of these cyclone disturbances. Okay, now moving forward, tropical cyclones originate over the Bay of Bengal and the Indian Ocean. These tropical cyclones have very high wind velocity and heavy rainfall and hit the Tamil Nadu, Andhra Pradesh and the Orissa coast. Okay, so these tropical cyclones mainly hit the Tamil Nadu region, Andhra Pradesh and Orissa coast. Most of these cyclones are very destructive due to high wind velocity and torrential rain that accompanies it. Okay, so that's about the tropical cyclones. Now, mechanism of weather in the summer season. So now we already discussed about the mechanism in the winter season. Next one is mechanism of weather in the summer season. So first one is surface pressure and the winds. Okay, surface pressure and the winds. As the summer sets in and the sun shifts northwards, the wind circulation over the subcontinent undergoes a complete reversal or at both. Okay, so as the summer sets in and the sun shifts northwards, the wind circulation over the subcontinent undergoes a complete reversal at both the lower as well as the upper levels. By the middle of July, the low pressure belt near the surface, that is termed as the intertropical convergence zones, ITCZ. Okay, so by middle of the July, the low pressure belt near the surface, that is ITCZ, shift northwards, roughly parallel to the Himalayan between 20° north and 25° north. By this time, the westerly jet streams withdraw from the Indian region. In fact, meteorologists have found an interrelationship between the northward shift of equatorial trough, that is ITCZ, and the withdrawal of the westerly jet stream from over the northern plain. It is generally believed that there is a cause and effect relationship between the two. The ITCZ, being a zone of low pressure, attract inflow of winds from different directions. The maritime tropical air mass, that is MT, from the southern hemisphere after crossing the equator rushes to the low pressure area in general southwesterly direction. This is the moist air current, which is popularly known as southwest monsoon. Okay, so do you know what is the process happening there? Look at this picture. Okay, look at this picture. So this is the equator, and here is India located, and this is normally ITCZ. But in summer season, what happened? The ITCZ have a slight increase, rise into northern hemisphere. Okay, so now this is ITCZ. What happened? So there are some trade winds. Okay, so these trade winds, okay, the southeastern trade winds, the southeast trade wind, when it reached the equator, what happened? ITCZ, this is a low pressure belt, so this attract the winds. The ITCZ attract the winds, okay, attract these southeast trade winds. But after crossing the equator, what happened? The winds have a turning into rightward because of the effect of Coriolis force. Okay, so when it crossed the equator, what happened? Because of the Coriolis force, they have a tendency to turn right, and this is known as the southwest monsoon. Okay, so the southeast trade winds, after crossing the equator, due to the effect of Coriolis force, it have a right turn, and this winds, and this is known as southwest monsoons. Okay, so that is the process. Now, next one is jet streams and upper air circulation. Jet streams and upper air circulation. The pattern of pressure and winds as mentioned above is formed only at the high level of troposphere. An easterly jet stream flows over the southern part of the peninsula in June and has a maximum speed of 990 km per hour. In August, it is confined to the 50° north latitude, and in September up to 22° north latitudes. The easterlies normally do not extend to the north of 30° north latitudes in the upper atmosphere. Okay, so that's about the jet stream and the upper air circulation. Now, the easterly jet stream and tropical cyclones. The easterly jet streams steer the tropical depression into India. These depressions play a significant role in the distribution of monsoon rainfall over the Indian subcontinent. So the tracks of these depressions are the area of highest rainfall in India. Okay, so the tracks of this depression, these are the areas of highest rainfall in India. The frequency at which this depression visit India, their direction and intensity all go a long way in determining the rainfall pattern during the southwest monsoon period. Okay, so that's about the easterly jet stream and the tropical cyclones. Now, the nature of Indian monsoon. Monsoon is a familiar thought, a little known climatic phenomenon. Despite the observations spread over centuries, the monsoon continues to puzzle the scientists. Many attempts have been made to discover the exact nature and causation of monsoon, but so far no single theory has been able to explain the monsoon fully. A real breakthrough has come recently when it was studied at the global rather than the regional level. Systematic studies of the cause of rainfall in the South Asian region help to understand the cause and the salient features of the monsoon. Particularly, some of its important aspects are: first one, the onset of the monsoon. Then the rain-bearing system, that is tropical cyclones, and the relationship between the frequency and distribution of monsoon rainfall and the break in the monsoon. Okay, so first let's discuss about the onset of monsoon. Towards the end of the 19th century, it was believed that the differential heating of land and sea during the summer months is the mechanism which sets the stage for the monsoon winds to drift towards the subcontinent. During April and May, when the sun shines vertically over the Tropic of Cancer, the large landmass in the north of Indian Ocean gets intensely heated. This causes the formation of an intense low pressure in the northwestern part of subcontinent. Since the pressure in the Indian Ocean in the south and the landmass is high as water gets heated slowly, the low pressure cells attract the southeast trade across the equator. These conditions helps in the northward shift in the position of ITCZ. Okay, so this condition helps in the northward shift of the position of ITCZ. We already discussed that. The southwest monsoon may thus be seen as the continuation of the southeast trade winds. Okay, so the southeast trade winds, this is equator, okay, and this is ITCZ. So the southeast trade wind, what happened when they cross the equator and have a directional change into the right, so that is known as southwest monsoon. So the southeast trade deflected towards the Indian subcontinent after crossing the equator. Okay, so after crossing the equator, the southeast trade winds have a deflection towards the Indian subcontinent. Okay, so they deflect towards the Indian subcontinent after crossing the equator. These winds cross the equator between 40° east and 60° east longitudes. The shift in the position of ITCZ is also related to the phenomenon of withdrawal of the westerly jet stream from its position over the North Indian plains. Okay, so this shift also helps to the withdrawal of westerly jet stream, and it is south of Himalayas. Okay, from the position over the North Indian plains, that is south of Himalayas. The easterly jet stream sets in along 15° north latitudes only after the western jet stream has withdrawn itself from the region. This easterly jet stream is held responsible for the burst of monsoon in India. Okay, so this easterly jet stream, this is held responsible for the burst of monsoon in India. Now, entry of monsoon into India. Okay, entry of monsoon into India. The southwest monsoon sets in over the Kerala coast by 1st June and moves swiftly to reach Mumbai and Kolkata between 10th and 13th June. By mid-July, southwest monsoon engulfs the entire subcontinent. Okay, so that is the entry of monsoon in India. The first one, the southwest monsoon, first reached over the Kerala coast by the June 1st, and it moves swiftly to reach Mumbai and Kolkata between the 10th and 13th June. And by mid-July, the southwest monsoon entirely flow to the subcontinent. Okay. Now, rain-bearing systems and the rainfall distribution. There seem to be two rain-bearing systems in India. First originate in the Bay of Bengal, causing rainfall over the plains of North India. Second is the Arabian Sea current of the southwest monsoon, which brings rain to the west coast of India. Okay, so there is two rain-bearing system in India. The first one is originating in the Bay of Bengal, causing rainfall over the plains of North India. Okay, which causes for the rainfall on the plains of North India. And second one is the Arabian Sea current of the southwest monsoon, which brings rain to the west coast of India. Much of the rainfall along the Western Ghats is orographic. Okay, because it is related to the mountains. So Much of the rainfall along the western Ghats is orographic as the moist air is obstructed and forced to rise along the Ghats. The intensity of the rainfall over the west coast of India is, however, related to two factors. First one, the offshore meteorological condition, the position of the equatorial jet streams along the eastern coast of Africa. Okay, so these are two factors which affect the intensity of rainfall over the west coast of India. Now, the frequency of the tropical depressions originate from the Bay of Bengal varies from year to year. Their path over India are mainly determined by the position of ITCZ. Okay, so the path is mainly determined by the intertropical convergence zone, which is generally termed as the monsoon trough. Okay, the ITCZ is generally termed as monsoon trough. As the axis of the monsoon trough oscillates, there are fluctuations in the track and direction of this depression, and the intensity and the amount of rainfall vary from year to year. Okay, so every year the monsoon didn't get the same amount of rain, so there is a variation of rainfall. The rain which comes in spells displays a declining trend from west to east over the west coast and from southeast towards the northwest over the north Indian plain and the northern part of the peninsula. Okay, so there is a slightly difference or variation in the rainfall also. Now, break in the monsoon. During the southwest monsoon period, after having rains for a few days, if rains fail to occur for 1 or more weeks, it is known as the break in the monsoon. Okay, so if the southwest monsoon, there is a break of few days in the rainfall, then this is called the break in the monsoon. These dry spells are quite common during the rainy season. These breaks in different regions are due to different reasons. Okay, the breaks in different regions, these are due to different reasons. In North India, rains are likely to fail if the rain-bearing storms are not very frequent along the monsoon route or the ITCZ over this region. Okay, so in the North Indian region, what is the reason? The rains are likely to fail if the rain-bearing storms, if the rain-bearing storms are not very frequent along the monsoon road or the ITCZ over this region. And next one, over the west coast, the dry spells are associated with the days when wind blows parallel to the coast. Okay, so in the western coast or west coast, the dry spells are associated with the days and when winds blow parallel to the coast. So these are some reasons for the break in monsoon in different regions. Now, the rhythm of seasons. Now let's discuss about some seasons. The climatic conditions of India can be described in terms of an annual cycle of seasons. The meteorologists recognize the following 4 seasons. So there are mainly 4 seasons in India. First one is the cold weather season, the hot weather season, the southwest monsoon, that is the monsoon season, and the retreating monsoon season. Okay, so these are the 4 seasons that experience in India. First one, the cold weather season, the hot weather season, the southwest monsoon season, that is called the monsoon season, and the retreating monsoon. Okay, the retreating monsoon is also known as northeast monsoon. Okay, so these are the 4 main seasons experienced in India. First one is the cold weather season. So let's look at the temperature of cold weather season. Usually, the cold weather season sets in by mid-November in the North India. December and January are the coldest months in the northern plain. The mean daily temperature remains below 21 degrees Celsius over the most part of northern India. Okay, so in North India, December and January are the coldest month, and the mean daily temperature that remains below 21 degrees Celsius over the most of the Indian states, North Indian states. The night temperature may be quite low, sometimes going below freezing point in Punjab and Rajasthan. Okay, so in Punjab and Rajasthan, it may be below freezing point, that is that much lower temperature. There are 3 main reasons for the excessive cold in North India during this season. Okay, so there are three reasons for the excessive cold in North India during this season, during the winter season. First one, states like Punjab, Haryana and Rajasthan being far away from the moderating influence of sea experiencing continental climate. Okay, so the states like Punjab, Haryana and Rajasthan, they are far away from the influence of sea. So that's why they experience continental climate. Second one is the snowfall in the nearby Himalayan ranges creates cold wave situation. Okay, so the snowfall in the Himalayan ranges, okay, because the Himalaya is situated in the northern parts of India. So the snowfall in the Himalayan ranges, nearby Himalayan ranges, it creates cold wave situation. Okay, and finally, around February, the cold winds coming from the Caspian Sea and Turkmenistan bring cold wave along with the frost and fog over the northwestern part of India. Okay, so around the month of February, the cold winds coming from the Caspian Sea and the Turkmenistan, they bring cold wave along with the frost and fog. Okay, this also create the northwestern parts of India in a winter mood or in a cold season. Now, the peninsular region of India, however, does not have any well-defined cold weather season. Okay, so the peninsular region, that is this region. Okay, this is the peninsular region. So the peninsular region of India, however, does not have any well-defined cold weather season. So this region does not have any kind of well-defined cold weather season. There is hardly any seasonal change in the distribution pattern of the temperature in coastal areas because of the moderating influence of the sea and the proximity to equator. For example, the mean maximum temperature for January at Trivandrum is as high as 31 degrees Celsius. For June, it is 29.5 degrees Celsius. Okay, so this is the difference. In Trivandrum, the January temperature may be 31 degrees Celsius and in June it is 29.5 degrees Celsius. So there is no that much differences. Temperature at the hills of Western Ghats remain comparatively low. Okay, so the hills of Western Ghats have a comparatively low temperature. Next one is pressure and wind. By the end of December, that is 22nd December, the sun shines vertically over the Tropic of Capricorn in the southern hemisphere. Okay, so now, so we know that on December 22nd, the sun is situated at the Tropic of Capricorn. Okay, they vertically over the Tropic of Capricorn. That is 23.5 degree south. The weather in this season is characterized by feeble high pressure condition over the northern plains. Okay, so because of the cold climate, it experiences high pressure condition in northern plains. In South India, the air pressure is slightly lower. The isobars of 1019 MB and 1013 MB pass through the northwest India and far south, respectively. As a result, the winds start blowing from northwestern high pressure zone to the low air pressure zone over the Indian Ocean in the south. Okay, so what happened? As a result, the winds start blowing from the northwestern high pressure zone, okay, from the northwest high pressure zone to the low air pressure zone over the Indian Ocean in south. Okay, so the wind blow from northwest to the south, that is the Indian Ocean region. Okay. Due to low pressure gradient, the light winds with a low velocity of about 3 to 5 km per hour begin to blow outwards. By and large, the topography of the region influences by the wind direction. They are westerly or northwesterly down the Ganga Valley. They become northerly in the Ganga-Brahmaputra delta. Free from the influence of topography, they are clearly northeasterly over the Bay of Bengal. During the winters, the weather in the India is pleasant. Okay, so the winter weather is pleasant in India. The pleasant weather condition, however, at intervals get disturbed by shallow cyclonic depression originated over the East Meridian Sea and traveling eastward across the West Asia, Iran, Afghanistan and Pakistan before they reach the northwestern part of the India. Okay, so normally the winter weather in the India is pleasant, but some factors because of the disturbed by shallow cyclonic depression originate over the East Meridian Sea and this travel eastward across the West Asia, Iran, Afghanistan, and Pakistan. And before they reach the northwestern part of India. Okay, so the this cyclonic depression, this originates over the East Meridian Sea. This creates a disturbance in the Indian winter season. Okay. On their way, the moisture content gets augmented from the Caspian Sea in the north and the Persian Gulf in the south. Okay, so on their way, the moisture content gets augmented from the Caspian Sea and the Persian Gulf. So next one is rainfall. Winter monsoon do not cause rainfall as they move from land to sea. Okay, they are moving from the winter monsoon or move from land to sea. So they do not cause rainfall. It is because firstly they have a little humidity. Okay, because they travel from land to ocean. Okay, land to sea. So what happened? The humidity was very less. Humidity was very low humidity. Secondly, due to anticyclonic circulation on land, the possibility of rainfall from then reduces. Okay, so the possibility of rainfall from them reduces because they are anti-circulation on land. And so most part of India do not have rainfall in the winter season. However, there are some expectations to it. Okay, so because of these reasons, most part of the India does not have rainfall on the winter season. But there are also some exceptions. First one, the northwestern India, some weak temperate cyclones from the Mediterranean Sea causes rainfall in Punjab, Haryana, Delhi, and the western UP. Although the amount is mere grey, it is highly benefit for the Rabi crops. So this amount or this rainfall can benefit for the Rabi crops. Okay. The precipitation is in the form of snowfall in the lower Himalayas. Okay, so the precipitation is in the form of snowfall in lower Himalayas. It is this snow that sustains the flow of water in the Himalayan rivers during the summer months. The precipitation goes on decreasing from west to east in the plains and from north to south in the mountains. The average winter rainfall in the Delhi is around 53 mm. In Punjab and Bihar, the rainfall remains between 25 mm and 18 mm respectively. Now, second one is central part of India and northern part of southern peninsula also get winter rainfall occasionally. Okay, so the central part of India and the northern part of southern peninsula, they also get winter rainfall occasionally. Arunachal Pradesh and Assam in the northeastern parts of India also have rains between 25 mm and 50 mm during these winter months. Okay, so the Arunachal Pradesh and Assam in the northeastern parts, these are rains between 25 mm and 50 mm during these winter months. Next one is during October and November, northeast monsoon while crossing over the Bay of Bengal picks up moisture and causes torrential rainfall over the Tamil Nadu coast. Okay, so during the October and November months, the northeast monsoon, okay, so the northeast monsoon while crossing over the Bay of Bengal, it picks up moisture and causes torrential rainfall over the Tamil Nadu coast. Also the southern Andhra Pradesh, southeast Karnataka and the southeast Kerala. Now let's discuss about the hot weather season. First one is temperature. Sorry. With the apparent northward movement of the sun towards the Tropic of Cancer in March, temperatures start rising in the North India. Okay, so to the apparent northward movement of the sun towards the Tropic of Cancer in March, the temperatures start rising in North India. April, May and June are the months of summer in the North India. In most part of India, temperatures recorded are between 30 degrees Celsius to 32 degrees Celsius. In March, the highest day temperature of about 38 degrees Celsius occur in the Deccan Plateau, while in April, the temperature ranging between 38 degrees Celsius and 43 degrees Celsius are found in Gujarat and Madhya Pradesh. Okay, so these are the summer temperature. In May, the heat belt moves further north, and in the northwestern parts of India, temperature is around 48 degrees Celsius are not uncommon. Okay, so in northwestern parts we can find the temperature is about 48 degree Celsius. That is, it's very much high temperature. Okay, it's high temperature. The hot weather season in South India is mild and not so intense as found in North India. Okay, so in South India, the summer season is also mild. The peninsular situation of South India with moderating effects of oceans keep the temperature lower. Okay, because the South India is South India, that is the peninsular condition of South India, and the moderating effect of oceans, they keep the temperature low. So temperatures remain between 26 degrees Celsius and 32 degrees Celsius. So in South India, the temperatures are between 26 degrees Celsius and 32 degrees Celsius. Okay. Due to altitude, the temperature in the hills of Western Ghats remains below 25 degrees Celsius. Okay. So the altitude, because of the altitude factor, the temperature in hills of Western Ghats, they remain below 25 degrees Celsius. In the coastal regions, the north-south extent of isotherms parallel to the coast confirm the temperature does not decreases from north to south. Rather, it increases from the coast to interior. Okay, so there is no temperature decreases from north to south, but there is an increases from coast to the interior. The mean daily minimum temperature during the summer months also remain quite high, as rarely goes below 26 degrees Celsius. Okay, so rarely it can below 26 degrees Celsius. So that is the effect of temperature in the summer season. Now, what is the effect of pressure and winds in summer season? The summer months are a period of excessive heat and falling air pressure in the northern half of the country. Because of the heating of the subcontinent, the IT season moves towards occupying a position centered at 25 degrees north in July. Roughly, this elongated low-pressure monsoon trough extends over the Thar Desert in the northwest to Patna and Chota Nagpur Plateau in the southeast. Now, the location of the ITZ attracts a surface circulation of winds which are southwesterly on the west coast as well as along the coast of West Bengal and Bangladesh. They are easterly or southeasterly over North Bengal and Bihar. It has been discussed earlier that these currents of southwesterly monsoon are in reality displaced equatorial westerlies. The influx of these winds by mid-June brings about a change in the weather towards the rainy season. In the heart of IT season in northwest, the dry and hot wind, that is known as Lu, blow in the afternoon, and very often they continue to well into midnight. Dust storms in the evening are very common during May in Punjab, Haryana, eastern Rajasthan and Uttar Pradesh. These temporary storms bring a welcome respite from the oppressing heat, since they bring with them light rains and a pleasant cool breeze. Occasionally, the moisture-laden winds are attracted towards the periphery of the trough. A sudden contact between dry and moisture air masses gives rise to local storms of great intensity. These local storms are associated with violent winds, torrential rains, and even hailstorms. Okay. Now let's discuss some famous local storms of the hot weather season. Okay. First one is mango shower. Towards the end of summer, there are pre-monsoon showers which are common phenomenon in Kerala and the coastal areas of Karnataka. Okay, so towards the end of summer, there is a pre-monsoon shower which are common in Kerala and coastal areas of Karnataka. Locally, they are known as mango showers, since they helps in the early ripening of mangoes. Okay, so due to these storms, or due to this mango shower, the mangoes are ripening early in Kerala and Karnataka coast. So that's why they are known as mango shower. Next one is blossom shower. With this shower, coffee flowers blossom in Kerala and the nearby areas. Okay, so because of the blossom shower, the coffee flowers blossom in Kerala and the nearby areas. Next one, nor'westers. These are dreaded evening thunderstorms in Bengal and Assam. Their notorious nature can be understood from the local nomenclature of Kal Baisakhi, a calamity of the month of Baisakhi. These showers are useful for tea, jute, and rice cultivation. In Assam, these storms are known as the Bardoli Chira. Okay, so that is about the nor'westers or the Kal Baisakhi. These are the dreaded evening thunderstorms in Bengal and Assam, and their notorious nature can be understood from the local nomenclature of the Kal Baisakhi. The Kal Baisakhi is a calamity of the month of Baisakh. Then these showers are useful for tea, jute, and rice cultivation, and in Assam, these storms are known as the Bardoli Chera. The final one is Lu. We already discussed about the Lu. That is a hot, dry, and oppressing winds blowing in the northern plains of the Punjab to Bihar. Okay, northern plains from Punjab to Bihar with higher intensity between Delhi and Patna. So this is called Lu. Okay, so this is a hot wind. Next one is the southwest monsoon season. Okay, southwest monsoon season. As a result of rapid increase of temperature in May over the northwestern plains, the low pressure condition over these get bifurcate further intensified. Okay, so as a result of the increase of temperature in May, okay, in May month the temperature then again increases, and this makes a low pressure condition over the northwestern plains. By early June, they are powerful enough to attract the trade winds of southern hemisphere coming from the Indian Ocean. Okay, so at the time of June, by early June, what happened? These low pressure conditions, they are enough powerful to attract the trade winds from the southern hemisphere. Okay, these trade winds are southeast trade winds. Okay, so this low pressure belt is or low pressure condition is powerful enough to attract the southeast trade winds. These southeast trade winds cross the equator and enter the Bay of Bengal and the Arabian Sea only to catch up the air circulation over India. Passing over the equatorial warm currents, they bring with them moisture in abundance. Okay, because they're passing over the equatorial warm currents and they bring with them moisture in abundance. After crossing the equator, they follow a southwesterly direction. Okay, we know why, because of the Coriolis force. Okay, what happened when crossing the equator? They have a rightward, that is the southwest direction. Okay, southwesterly direction. That is why they are known as southwest monsoon. Okay. The rain in the southwest monsoon season begins rather abruptly. One result of the first rain is that it brings down the temperature substantially. This sudden onset of the moisture-laden winds associated with violent thunder and lightning is often termed as the break or the burst of the monsoon. The monsoon may burst in the first week of June in the coastal areas of Kerala, Karnataka, Goa, and Maharashtra, while in the interior parts of the country, it may be delayed to the first week of July. The day temperature registered a decline of 5 degrees Celsius to 8 degrees Celsius between mid-June and mid-July. As these winds approach the land, the southwardly direction is modified by the relief and thermal low pressure over the northwest India. The monsoon approaches the landmass in two branches, that is the Arabian Sea branch and the Bay of Bengal branch. Monsoon winds of Arabian Sea. Okay. The monsoon winds originate over the Arabian Sea, further splits into three branches. Its one branch is obstructed by the Western Ghats. These winds climb the slopes of Western Ghats from 900 to 1200 meters. Soon they become cool, and as a result, the windward side of the Sahyadris and western coastal plains receive very high rainfall. Okay, that is ranging between 250 centimeter to 400 centimeter. Okay, so the first one is the first one of the monsoon winds of Arabian Seas. It is a branch which is obstructed by the Western Ghats, and they the wind climbed the slopes of Western Ghats from 900 to 1200 meter, and soon they become cool, and as a result they shed the rain in the windward side of the Sahyadris and the western coastal plains, and this area receive very high rainfall ranging between 250 centimeter and 400 centimeter. After crossing the Western Ghats, these winds descend and get heated up. This reduces the humidity in the winds. As a result, these winds cause little rainfall east of the Western Ghats. This region of low rainfall is known as the rain shadow area. Okay. Now, another branch of Arabian Sea monsoon strike the coast of Mumbai, moving along the Narmada and Tapi river valleys. These winds causes rainfall in extensive areas of central India. The Chota Nagpur Plateau gets 50 centimeter rainfall from this part of branch. Thereafter, they enter the Ganga plains and mingle with the Bay of Bengal branch. Okay, so the second branch is it strikes the coast north of Mumbai and moving along the Narmada and Tapi river valleys, and this winds causes rainfall in extensive areas of central India, and they cause 15 centimeter rainfall in the Chota Nagpur Plateau, and after they enter the Ganga plains and mingle with the Bay of Bengal branch. Now the third branch of this monsoon wind strikes the Saurashtra Peninsula and the Kutch region. It then passes over the West Rajasthan and along the Aravallis, causing only a scanty rainfall. In Punjab and Haryana, it too joins the Bay of Bengal branch. Okay, so in Punjab and Haryana, it joins with the Bay of Bengal branch. These two branches reinforced by each other causes rains in the western Himalayas. Okay, so they too reinforced by each other and they cause rains in the western Himalayan region. So that is the monsoon winds of Arabian Sea. Next one is the monsoon winds of the Bay of Bengal. The Bay of Bengal branch strikes the coast of Myanmar and the part of southeast Bangladesh. But the Arakan hills along the coast of Myanmar deflect a big portion of the branch towards the Indian subcontinent. The monsoon therefore enters West Bengal and Bangladesh from south and southeast instead of from the southwesterly direction. From here, this branch is split into two under the influence of the Himalayas, and the thermal low is northwest India. Its one branch moves westward along the Ganga plains, reaching as far as the Punjab plains. The other branch moves up the Brahmaputra valley in the north and the northeast, causing widespread rain. Its sub-branch strikes the Garo and Khasi hills of Meghalaya. Mosoram, located on the crest of Khasi hills, receive the highest average annual rainfall in the world. Now, here it is important to know why the Tamil Nadu coast remains dry during this season. There are two factors responsible for it. First one, the Tamil Nadu coast is situated parallel to the Bay of Bengal branch of southwest monsoon. And second one, it lies in the rain shadow area of Arabian Sea branch of southwest monsoon. Okay, so first one is the Tamil Nadu is situated parallel to Bay of Bengal branch, and second one is lies rain shadow area of the Arabian Sea branch. So these are the two conditions, or these are the two situations of these are the two factors responsible for Tamil Nadu's less rainfall or Tamil Nadu's dry season during the monsoon season. Now, characteristics of monsoon rainfall. Rainfall received from the southwest monsoon is seasonal in character, which occurs between June and September. Okay, so what is the time period of monsoon? It's between June and September. The monsoonal rainfall is largely governed by relief or topography. For instance, the windward side of the Western Ghats register a rainfall of over 250 cm. Again, the heavy rainfall in the northeastern states can be attributed to their hill ranges and the eastern Himalayas. Now, the monsoon rainfall has a declining trend with increasing distance from sea. Okay, so they have a declining trend with increasing distance from the sea. Kolkata receives 119 cm during the southwest monsoon period, Patna 105 cm, Allahabad 75 cm, and Delhi 56 cm. So, because there is a decline in the increasing distance, okay, decline trend of monsoon with increasing distance. Now, The monsoon rains occur in wet spells of few days duration at a time. The wet spells are interspersed with a rainless interval known as the breaks. These breaks in rainfall are related to the cyclonic depressions mainly formed at the head of Bay of Bengal and they are crossing into the mainland. Besides the frequency and intensity of this depression, the passage followed by them determines the spatial distribution of rainfall. Okay, so this determines the spatial distribution of the rainfall. Next one is the summer rainfall comes in a heavy downpour leading to considerable runoff and soil erosion. Okay, so this may cause the considerable runoff and soil erosion. Monsoon play a pivotal role in the agrarian economy of India because over 3/4 of the total rain in the country is received during the southwest monsoon season. Okay, over the 3/4 of total rain in country is received during the southwest monsoon. Next one is its spatial distribution is also uneven, which ranges from 12 cm to more than 250 cm. Okay, so that is the spatial distribution of monsoon. It's from 12 cm to 250 cm. The beginning of the rains sometimes is considerably delayed over the whole or a part of the country. The rain sometimes ends considerably earlier than usual, causing great damage to standing crops and making the sowing of winter crops difficult. Okay, sometimes the monsoon may considerably end very earlier than usual, and this causes damage to the standing crops and some winter crops. Okay, so some winter sowing crops. Now, next one is season of retreating monsoon. The month of October and November are known for the retreating monsoon seasons. By the end of September, the southwest monsoon becomes weak as the low pressure throat of the Ganga plains start moving southward in response to the southward march of the sun. The monsoon retreats from the western Rajasthan by the first week of September. It withdraws from Rajasthan, Gujarat, western Ganga plain and the central highlands by the end of the month. By the beginning of October, the low pressure covers northern parts of the Bay of Bengal and by early November it moves over Karnataka and Tamil Nadu. Okay, so by early November this low pressure moves over the Karnataka and Tamil Nadu region. By the middle of December, the center of low pressure is completely removed from the peninsular region. The retreating southwest monsoon season is marked by clear skies and a rise in temperature. The land is still moist, owing to the condition of high temperature and humidity. The weather becomes rather oppressive. This is commonly known as the October heat. In the second half of the October, the mercury began to fall rapidly, particularly in the northern India. The weather in the retreating monsoon is dry in North India, but it is associated with rain in the eastern part of the peninsula. Okay, so in North India, the weather is dry, but it's associated with rain in the eastern part of peninsula. Here, October and November are the rainiest months of the year. The widespread rain in this season is associated with the passage of cyclonic depression which originated over the Andaman Sea and managed to cross the eastern coast of the southern peninsula. These tropical cyclones are very destructive. The thickly populated deltas of Godavari, Krishna and the Kaveri are their preferred targets. Every year, cyclones bring disasters here. A few cyclonic storms also strike the coast of West Bengal, Bangladesh and Myanmar. A bulk of the rainfall of the Coromandel coast is derived from these depressions and cyclones. Such cyclonic storms are less frequent in the Arabian Sea. Okay, so such cyclones are very less in the Arabian Sea. Okay, most of the cyclones are formed in the Bay of Bengal region. Now, traditional Indian season. In the Indian tradition, a year is divided into 6 2-monthly seasons. This cycle of seasons, which the common people in North and Central India follows, is based on their practical experience and age-old perception of weather phenomena. However, this system did not match with the season of South India, where there is little variation in the season. Now, the distribution of rainfall. The average annual rainfall in India is about 125 cm, but it has great spatial variation. First one, the area of high rainfall. The highest rainfall occurs along the west coast on the Western Ghats as well as in the sub-Himalayan areas is the northeast and hills of Meghalaya. Okay, so these are some of the places which occur highest rainfall. West coast on the Western Ghats, then in the sub-Himalayan areas is in the northeast and the hills of Meghalaya. Here the rainfall exceeds 200 cm. In some parts of Khasi and Jaintia hills, the rainfall exceeds 1000 cm. In the Brahmaputra valley and the adjoining hills, the rainfall is less than 200 cm. Next one is areas of medium rainfall. Okay, areas of medium rainfall. First one is areas of high rainfall. Next one is area of medium rainfall. A rainfall between 100 to 200 cm is received in the southern part of Gujarat, East Tamil Nadu, northeastern peninsula covering Orissa, Jharkhand, Bihar, eastern Madhya Pradesh, northern Ganga plain, along the sub-Himalayan and the Kachha valley and Manipur. Okay, so these are the places which affect medium rainfall. Next, areas of low rainfall. Western UP, Delhi, Haryana, Punjab, Jammu and Kashmir, eastern Rajasthan, Gujarat and the Deccan Plateau receives rainfall between 50 to 100 cm. Areas of inadequate rainfall. Okay, so last one is areas of inadequate rainfall. Parts of the peninsula, especially in Andhra Pradesh, Karnataka and Maharashtra, then Ladakh, and these are the most of the western Rajasthan receive rainfall below 50 cm. Okay, so the Andhra Pradesh, Karnataka, Maharashtra, Ladakh and western Rajasthan, these places receive below 50 cm rainfall, and snowfall is restricted to the Himalayan region. Now, variability of rainfall. A characteristic feature of rainfall in India is its variability. Okay, the variability of rainfall is computed with the help of the following formula. That is, CV is equal to standard division by mean into 100, where the CV is the coefficient of variation. Okay, so what is variation? Let's discuss. The value of coefficient of variation shows the change from the mean value of rainfall. The actual rainfall in some places deviates from 20 to 50%. The values of coefficient of variation shows variability of rainfall in India. A variability of less than 25% exists on the western coast, Western Ghats, northeastern peninsula, eastern plains of Ganga, northeastern India, and Uttaranchal, that is Uttarakhand and Himachal Pradesh, and the southwestern part of Jammu and Kashmir. These areas have an annual rainfall over 100 cm. A variability of over 50% exists in the western part of Rajasthan, northern part of Jammu and Kashmir, and the interior part of the Deccan Plateau. These areas have an annual rainfall of less than 50 cm. Rest of India have a variability of 25 to 50% and these areas receive an annual rainfall between 50 to 100 cm. Okay. Next one is the climatic regions of India. The whole India has a monsoon type of climate, but the combination of elements of the weather, however, reveal many regional variations. These variations represent the subtypes of monsoon climate. It is on this basis that the climatic regions can be identified. A climatic region has a homogeneous climatic condition which is the result of a combination of factors. Temperature and rainfall are two important elements which are considered to be decisive in all the schemes of climatic classification. Okay, so the temperature and rainfall are two important elements. The classification of climate, however, is a complex exercise. There are different schemes of classification of climate. Major climatic types of India is based on Köppen's scheme have been described below. Köppen based his schemes of climate and classification on monthly values of temperature and precipitation. He identified 5 major climatic types, namely, first one, the tropical climates, where mean monthly temperature throughout the year is over 18 degrees Celsius. Second one is the dry climates, where the precipitation is very low in comparison to temperature and hence dry. If dryness is less, it is semi-arid. If it is more, then climate is arid. Next one is warm temperature climate, where the mean temperature of the coldest month is between 18 degrees Celsius and minus 3 degrees Celsius. Next one is cool temperature climate, where mean temperature of the warmest month is over 10 degrees Celsius and the mean temperature of the coldest month is under minus 3 degrees Celsius. Next one is ice climates, where mean temperature of the warmest month is under 10 degrees Celsius. Now, Köppen used letters symbols to denote climatic types as given above, which types is further subdivided into subtypes of the basis of seasonal variations in the distributional pattern of rainfall and temperature. He used S for semi-arid and W for arid, and the following small letters to define subtypes. F, that is sufficient precipitation. M for rainforest despite a dry monsoon season. W for dry season in winter. H for dry and hot. C, less than 4 months with mean temperature over 10 degrees Celsius. And G, Gangetic plains. Accordingly, India can be divided into 8 climatic regions. Okay. Next one, monsoon and the economic life in India. Monsoon is that axis around which revolves the entire agriculture cycle of India. It is because about 64% people of India depends on agriculture for their livelihood and agriculture. Agriculture itself is based on the southwest monsoon. Except Himalayas, all the parts of the country have temperature above the threshold level to grow the crops or plants throughout the year. Now, regional variations in monsoon climate help in growing various types of crops. Next, variability of rainfall brings droughts or floods every year in some part of the country. Agriculture prosperity of India depends very much on timely and adequately distributed rainfall. If it fails, agriculture is adversely affected, particularly in those regions where means of irrigation are not developed. Okay, so it's mainly affect the places where means of irrigations are not developed. Next one, sudden monsoon bursts create problems of soil erosion over large areas in India. Then winter rainfall by temperate cyclones in North India is highly beneficial for rabi crops. Next, regional climatic variations in India is reflected in the vast variety of food, clothes and house types. Now, what is global warming? Have you heard about global warming? The large part of Earth is under ice cover. Besides the natural causes, human activities such as large-scale industrialization and presence of polluting gas in the atmosphere are also important factors responsible for the global warming. The temperature of the world is significantly increasing. Carbon dioxide produced by human activities is a major source of concern. This gas released to the atmosphere in large quantities by burning fossil fuels is increasing gradually. Other gas like methane, chlorofluorocarbons, that is CFCs, and nitrous oxide, which are present in much smaller concentration in the atmosphere, together with carbon dioxide are known as greenhouse gases. Okay, so the methane, chlorofluorocarbons, nitrous oxides, then carbon dioxide, and other these are together known as greenhouse gases. Now, these gases are better absorbers of long-wave radiations than carbon dioxide and so are more effective at enhancing the greenhouse effect. These gases have been contributing to the global warming. It is said that due to global warming, the polar ice caps and mountain glaciers would melt and the amount of water in the oceans would increase. Now, the mean annual temperature of the Earth in the past 150 years has increased. It is projected that by the year 2100, global temperature will warm about 2 degrees Celsius. This rise in temperature will accompany many other changes. One of these is a rise in sea level as glacier and sea ice melt in response to warming. According to the current prediction, on an average, the sea level will rise a 48 centimeter by the end of 21st century. Okay, so according to the current prediction, an average the sea level will rise 48 centimeter by the end of 21st century. This would increase the incidence of annual flooding. climatic change would promote insect-borne diseases like malaria and lead to shift in climatic boundaries, making some regional wetter and other drier. Agriculture pattern would shift and human population as well as the ecosystem would experience change. Okay, so this is about the chapter. If you have any doubts, you can comment below. For more videos, do like, share, subscribe.